Hey everybody, thank you for joining us today for the first webinar of 2025. My name is Jenny Novak and I'm the marketing manager here and help coordinate the webinars. Welcome back if you've joined us for a webinar in the past, or if this is your first webinar, thanks for being here. We have a record turnout today, so we're excited about that. Just a quick intro about us. Dyne is an independent testing laboratory. We've been doing testing of firefighting foam for over 25 years. We also test antifreeze, dry chemical agents, and sprinklers, which we are going to be talking about today. Last year, we were acquired by NFPA Global Solutions, and as you might have noticed, we've been doing some rebranding, and while we continue to provide the same fast, reliable service and quality test results you've come to know us for. We always are asked if we're certified or accredited. Yes, Dyne is ISO 9001 certified and has a 17025 accreditation by A2OA for our automatic field sprinkler testing. Just a little housekeeping before we get started. If you have any questions during the presentation, we do like to hold a Q&A at the end of the content. So feel free to find that Q&A panel or the chat panel. We'll take questions in either one. And we'll save those up and have a little session at the end. If you stay until the end of the webinar, you will receive a certificate of attendance for today. I emailed those out separately. Some people use our webinars for NICEP credits and such. This webinar is being recorded, and you also receive a link to the video in my follow-up email, and a few other things, including a survey and some other things that we're going to be showing you today. Today's webinar, NFPA 25 sprinkler testing, will be presented by Grant Lobdell, who is the president at Dyne and has extensive knowledge of the firefighting foam, sprinkler, dry chemical, and antifreeze, as well as the NFPA 25 requirements. I'd like to turn it over to Grant to talk to us about sprinkler testing.
Thank you, Jenny, for the introduction. Yeah, she said I'm the president here at Dyne Fire Protection Labs. If you guys have attended these webinars before, you've seen me many times. You may have even heard me talk on this subject before. I hope you still are able to pick up something every time you listen. And for those that are new, welcome. I hope you learn lots today. So let's actually start right from the beginning. A lot of what I'm going to show today on screen will be the code, but I'm going to talk about it, kind of break it down. We'll take it section by section, just so you have a better understanding about where these requirements come from, what they might mean. So we are talking about today NFPA 25, which is the standard for inspection, testing, and maintenance of water-based fire protection systems. The audience here, you are probably well familiar, but you may hear me say ITM. That just stands for inspection, testing, and maintenance. The requirements shown on screen and that I'll be talking about will be from the 2023 edition. Got my book right next to me. I realize many of your states may be on the 2020 or 2017. I got them all right here. We always refer to at the laboratory here the most current edition, which is the 23. The next one is going to be 2026. And that one should probably release near the end of the year, I would guess. So when you hear me talking about requirements, I am going to reference the most up-to-date information that's been released. I will try to call out sections that maybe are different if you are on a previous edition as I go through this. So in that document, what are we talking about today is really this one sentence here at 5311. This is the heart of everything we're going to talk about today. It says, where required by section 5.3, sample sprinklers shall be submitted to an approved testing laboratory for field service testing, right? And we'll break that down. We're required by section 5.3. I didn't show every section there of every when sprinklers need to be tested. It's a lot to show on screen. Instead, what I've shown is a postcard. And I think Jenny will send this out with the certificate and the link after the webinar. It's just something you can keep handy for yourself. One side shows this interval. The other side talks about sampling requirements, which we'll get into shortly. But I've broken it down here on screen and really tried to make it as digestible as possible about the intervals for testing. If you've heard me talk about some of our other services like foam, that's every year. Unfortunately, it's not that simple with sprinklers. We have requirements all over the place. And that's not to try to make it difficult. It just happens to be the environment we're currently in. Some sprinklers haven't been around as long, don't have as much data. Some sprinklers, we had some data and there was high failure rates. We had to test more often. And there's different, speaking of environments, different environments these sprinklers can end up in. So what I like to say, if you're trying to break down, well, when do I need to test sprinklers? Number one, you're going to take the most stringent requirement. So you may have, when I'm going to talk about these, you may have a sprinkler in a harsh environment and it's also fast response. The most strict requirement, the most stringent is going to be that 5-year requirement if it meets both. So just keep that in mind as I talk about these. So let's start off at the most frequent, which is your sprinklers in harsh environments. That's going to be every 5 years. And I'm going to talk about this now because I know it'll come up in a question if I don't. Well, what is a harsh environment? NFPA 25 or NFPA in general in the document there does not have a formal definition of harsh environment. They do give some examples in the annex, and you'll see me bring up annex material throughout this. So let me just briefly educate you on that if you're not familiar. Anything with an A before the section that I show is annex material coming from Annex A, which should be thought of as more explanatory material. It's more shoulds than shalls. I know some jurisdictions do adopt some of that language and make it shall, but that's what I'm talking about when I talk about annex material explanatory. So even though harsh does not have a formal document, a formal definition, sorry, it does have examples. You know, it talks about forge shops, fumigation areas, tanneries, paper mills. When I hear all those words, I'm thinking about corrosive environments is really what I'm thinking of. Those all sound like they may have some chemicals that may corrode the sprinkler. That could be harsh. I think about myself, swimming pools. If I have an indoor swimming pool in an apartment complex or something, that could be considered harsh. I may have lots of moisture that's going to corrode the sprinkler a little bit quicker than if it was just in a conditioned office space like that. So while I can't give you a formal definition, it is somewhat up to interpretation of what harsh is. You really have to just think about, okay, is this sprinkler, if it was in an office, just aging along, or I'm in somewhere where there's some chemicals or some moisture, something that's going to accelerate that aging beyond what's typical. So that's your harsh environment. Now, while we'll call out that sprinklers in harsh environments, but they have some sort of corrosion listing component to it, whether that be the material they're made of or some sort of coating, you can actually push those back to 10 years. I believe this is a new sentence, a new section in NFPA 2023, I believe. In previous editions, it didn't separate that out. There was anything in harsh is 5, whether or not you paid extra to get some sort of extra corrosion listed plating or material, they didn't care. That got brought to the committee. Committee decided, nah, we should give, you paid a lot more to have this corrosion resistant feature. So if it is listed, so if it's been evaluated and listed as corrosion resistant, you can push that to 10 years. So that's the exception there. So we have our 5 years in harsh. Let's say you are I'm sitting in a conditioned office space right now. I'm not harsh. Okay. What's next? It's going to be ESFR, CMSA, and dry sprinklers. They're all at 20, all 3 of those types. And this is something, again, if you're in previous edition, your ESFR and CMSA, those weren't separated before. You're correct. Used to just say fast response and dry sprinklers. So they separated out fast response to ESFR and CMSA and your dry sprinklers. Another change that's happened over the last few years is dry sprinklers. I think in the 2017, it used to say at 15 years or 10 years. I think at 2020, it said then it was 15, and now we're up to 20. Let's talk briefly about why that interval has changed over the years. So for many years, in the late 90s, early 2000s, we had a lot of O-ring sprinklers, or sorry, 90s, a lot of O-ring sprinklers. Dry sprinklers had a whole bunch of those O-rings, and it had a high failure rate as a result. We'll talk about failure rates a little bit later. So for many years, dry sprinklers had a known, okay, they have a high failure rate. We're gonna have to get those more often. But an O-ring sprinkler hasn't been listed, it's been over 20 years now. So we're starting to work through all those. We occasionally get some, and when I talk about statistics, I'll share with you how many O-ring sprinklers we still see in the market. But as we start to dwindle down, that failure rate on dry sprinklers has gone down considerably to where now we're comfortable. Okay, we can wait till 15, we can wait to 20. I believe the committee's intent is it's not to have all these different frequencies. They do want to try to, let's just have a couple numbers to remember, guys. I think they will push that maybe to 25 with fast. It's all data driven, whether or not the failure rate's low enough to where the committee feels comfortable. Yeah, we can wait a bit longer. But that's where we got our dry sprinklers, ESFR, they're all in the 20 years. Fast response at 25. So again, I'm going to bring up if you have a dry sprinkler that's fast response, you are going to be at the 20. That's your more strict requirement. But if you just have your standard sprinkler, fast response in some sort of, let's say, residential dwelling area, you're gonna be doing those every 20 or initial test at 25 years. And then all others, so basically your standard response sprinklers, are going to be at 50 years. So there's your requirements. Now I know it's a lot to remember, which is why we try to provide you a postcard. We provide more information. But right now we have the 5 years. And
for just a second, a lot
yeah,
of people
go ahead.
seeing the PowerPoint. So I'm wondering if we can maybe close it and try reloading it.
I can try that. Yeah, if people are having trouble seeing it. Yeah, why don't we try that?
I can see it from inside the office, but others are having problems with the PowerPoint.
Okay, I'm going to throw this ad up and I'm going to close it and we'll try to reopen it. It's loading up right now. Just getting a white screen on mine. Let me try reloading it once more. And the slides will be shared after too, but yeah, if many people can't see it, I would like them to be able to see the language on screen. Currently loading it up again. On my screen again, it shows it loaded up. Why don't we take a moment just to, if you can confirm with the chat, make sure it's loaded up.
Getting some yeses and some nos, so we'll probably just have to continue. And we will send out the recording, so sorry about the technical glitches, but we can send you the recording and the video so you don't miss anything.
Yeah, recording, the slides will be there. I'll try to, in my back of my mind, remember, hey, some people maybe can't see the wording on screen. I will be reading a bunch of it as well, so we'll proceed as we've been going here. So just to start over, we were starting field service requirement, NFPA 25, current editions 2023. I read on screen that it says, look, where required by NFPA 25 in section 5.3, samples shall be submitted to approved testing lab. I went through, kind of broke down, okay, here's our requirements. We got 5 for harsh, exceptions 10 if you have a corrosion resistant sprinkler. And then we have 20 for ESFR, dry sprinklers, 25 for fast, and 50 for all other. Now that's your initial test. After it's been installed, you are expected, let's say you initially take your sample, and we'll get into that. You send it to a laboratory, it passes, great. They can remain in service, but not indefinitely. You're going to have to do subsequent testing every 5 or 10 years. And that all depends, again, if you're in a harsh environment or not. At that point, it doesn't matter about, oh, is it ESFR or is it fast? Nope, it's just 5 or 10 for the subsequent testing if it passes, right? If you have failures and you got to replace, now you're back, you're starting the clock over. It's whether it's 5, 20, 25, 50, whatever sprinklers you have, an environment you have, you're back to that. So that is our testing interval. You need to know when the sprinklers were installed, not manufactured, installed. And then you need to, okay, have they been installed for 5, 20, 25? You need to understand what type of sprinkler you have. Again, it's broken by environment, and then dry, ESFR, fast, and then everything else is just falls in the bucket of 50 years. The frequencies, again, have changed over the years, just failure rates, new technology, fast response. Why is that not the same as standard? Just newer technology. We haven't got 50 years worth of data to go that far yet. Some key exceptions in the back of my mind when I'm looking at these years. Harsh environment, keep in mind that could not only be corrosive, but could be high temperature. So NFPA 25, NFPA comes from NFPA 13, has a maximum allowable sealing temperature. So I believe if you're 155, I think it's about 100 degrees Fahrenheit. There was a maximum allowable sealing temperature that addresses some of the issues with, like, let's say, solder migration, where you start to get really hot. Not hot enough to where it'll activate, but hot enough where the solder becomes sort of malleable. It can what we call migrate. It can kind of move around and then reharden and it weakens it. And then you have premature activation. So there is a specific clause of that 5 years if you have high temperature sprinklers with that are exposed to temperatures above the maximum sealing temp. So there are a few exceptions to just keep in mind as you look at the document. Another one you may run into is any sprinkler manufactured before 1920. Those should just be replaced. That's just a code requirement. If you send them, we will test you and get you data, but it'll automatically fail no matter what the data is. And if you ask, well, why do you even test it then? I had the same question myself. I've had this conversation with customers many times of sprinklers that, and we'll get into the floor level inspection, that clearly are going to fail. And I understand many of you contractors listening, you know it's going to fail and you know it needs to be replaced, but you have a building owner that wants a piece of paper that says, yep, you have a third party that said, yes, it does need to be replaced, or they want that data to prove it is going to fail. So we do still provide that. Let's talk about one other part of this section before we move on in this requirement. We talked about, okay, we're going to send sample sprinklers in as required here. We just went through the interval. The other part it says is to an approved testing laboratory. Now, NFPA, no definite, they have in the annex an explanation, if you will, for what approved is, but in there it tells you NFPA does not approve any laboratory. The next best thing is we look to the annex material, gives an example of some sort of qualification, accreditation, if you will, that could be used to demonstrate acceptability. And in this case, it references ISO 17025, which is an ISO standard for just competence of laboratories and calibration houses and things like that. You'll see later when I talk about Dyne, but we do carry that accreditation. Acceptability really comes down to your AHJ, whether that's your fire marshal, your inspector, your insurance company, and we work with those individuals. If any of you contractors, you have an AHJ, wants to learn more about Dyne, how we're doing things, certainly put them in touch with us. We're more than happy to share information and get them comfortable. And the last part of that is you're going to send it in for the field service test. This is what we're talking about today. Many of you listen, you may call it the UL test. For many years, they were the only ones doing it. Technically, it is just the field service test, the NFPA 25 test. That's what we're talking about today. So now that we understand we have to talk, or we have to either replace or test samples periodically. Let's say you've chosen, okay, I am going to test. I'm not going to replace every sprinkler in the building at year 50 or year 25, whenever it's due. I'm going to sample and I'm going to get some tested. I always like to bring up before sampling, there's a step that needs to be done by the contractor in the field, whether that be the building owner themselves or their designated representative, whoever's qualified to do this work. Sprinklers should first be given an inspection. That floor level inspection, that 5211 addresses in NFPA 25. So you're going to look through from a floor level, all your sprinklers, anything that shows leakage, corrosion detrimental to sprinkler performance, physical damage, loss of fluid in the glass bulb, loading detrimental to performance, or paint other than that applied by the sprinkler manufacturer detrimental to sprinkler performance. So there's a lot there. Let's just break that down a little bit here. And I've shown some samples on screen. So any sprinkler that shows these signs, we're just going to replace right then. We're not going to take those samples and send to a lab unless they truly are representative of all the sprinklers in the area. And you got an owner that's not willing to replace until we test. But ideally, you may have one, it's in a weird area where there's some fumes or some extra moisture. Maybe it's got some leakage. What's shown on screen, I hope those of you that can see the PowerPoint can see this. If not, again, these will be shared after. We have many pictures here of sprinklers throughout. We also have online pictures that we can share as well. But what I'm showing on screen on the far left is a sprinkler with leakage. We notice a lot of corrosion around that water seal. That's a good indicator of leakage, right? I don't have corrosion throughout. The whole frame, the deflector is not really showing much corrosion. I'm really showing it around the water seal. So that would be a good one for leakage. You may not always have drips. You may not have buckets of water that's coming out, right? It may come out, evaporate, just slowly corrode around it. That's a good sign there. This is also falls right in line with corrosion, detrimental to sprinkler performance. So we have that phrase, detrimental to sprinkler performance, 3 times throughout here. We have loading, corrosion, and paint. We'll get into that paint one's a bit different than the previous edition, but what is detrimental, right? And I would tell you, and we have a slide at this at the end, if you aren't sure, you can get it tested. We do have some data sheets online that show different sprinkler, that show you a sprinkler that's kind of on the edge. Is this detrimental or not for loading and corrosion? Let me give you the results, right? It's a judgment call. I can't tell you for sure, yes, it'll fail or it'll pass, but I can just give you, here's some data, guys. Here's a bunch of sprinklers and here's how it turned out when I tested them. So we try to help you with that phrase, if you will, but again, any question, let's just get it tested. So corrosion, this has leakage, but it's also, that is corrosion detrimental to the sprinkler. In this case, the sprinkler was tested, the water seal broke, the activation mechanism broke and the water seal remained in place. When we talk about failures, that's the most common failure, is the water seal remaining in place. Physical damage for my picture here, I've just, someone definitely over torqued the sprinkler. You can see the teeth marks on it. You can see it's no longer a round shape, it's an oval. So you can imagine a round, a circle water seal is not going to cover an oval very well, right? You're going to get some leakage and other damage like that. Let's hope this one was just damaged on removal, not installation. But physical damage, also the deflector on that one you can see is bent. That's very important. It's not something we analyze as part of the periodical test, the water distribution pattern, right? That should be, it was tested when it was listed. And then as long as it's still in the same shape, we should be good. But if there's any loading lodged in there, the deflector's been bent, you are no longer going to get the water distributed in the areas that it's intended for that you want. Loss of fluid in the glass bulb, that's actually in my picture on the far right. You got to be careful with this one now, because sometimes the fluid in there can change, can lose its color, if you will. I think in freezers it talks about, and UV light can sometimes, the dye in solution, typically the bulb's filled with some sort of alcohol and dye, it can lose its color. So how can you, well, it looks translucent to me. How can you see if there's fluid in there or not? You really want to look for a little air bubble, right? When they make these, that air bubble's put in there, and the bigger the air bubble, the longer it's going to take to go off. That's how you can manipulate those bulbs to give you different temperature ratings. So if there's no air bubble, maybe it is missing the fluid, okay? So that's just something you can look for on that. But you want to look and make sure there's if it has lost fluid, right, it ain't going to work like you expect. We joke that it's going to go off, but at the melting point of glass, right? It's not going to be until that glass melts that the sprinkler will go off, instead of the fluid, the alcohol expanding, putting pressure on the bulb and breaking. Another phrase here, detrimental to sprinkler performance, in this case, loading. On my screen, I've got, I don't know if it's a hornet, I can't remember what exactly it was, but some sort of insect has built a little nest on the deflector there, right? Clearly, we're not going to get the water distribution pattern we want. All right, so that would definitely be loading, detrimental to performance right there. Any sprinkler that shows this, we're just going to replace right away. We're not going to take and send that to the lab unless, again, you got a building owner that, no, I really need to see that data. And the last one, paint. Other than that applied by the sprinkler manufacturer, detrimental to sprinkler performance. This is something that changed over the, I believe, the last edition. It used to just say paint, other than that applied by the manufacturer. Did not matter where it was. It could be on the frame. It could be on a little bit in the inside of the deflector where it's not going to affect the water distribution pattern. But now they've gone through enough arguments of having to the committee, look, little bit of paint, a little bit of overspray on the side and the arm on the deflector, that is not going to impact performance. So they've added the phrase detrimental to sprinkler performance. So we're really looking at paint on the release mechanism. In this case on screen, I'm pointing to a fusible link that has paint holding it together. So on the release mechanism, we could have paint around the water seal. Maybe the fusible link goes off, but the water seal remains in place. That's because the paint could be holding it on. You could also be talking about paint in the teeth of the deflector, right, where we're going to affect the water distribution pattern. So that's just a quick rundown of, look, you're going to look for this before sampling for the laboratory. You're going to go through, as you do every year, an annual floor level inspection. You're going to look for these signs, and you're going to replace any sprinkler that has these signs. And then anything that remains, that's what we're going to sample from. Okay? So that's before sampling. Now let's actually talk about sampling. Okay, so we've gone through, we've decided, we understand it's a requirement. Let's say on screen here, I'm showing some standard response sprinklers. They're not in a harsh environment. So these I need to test after 50 years. Okay, I've talked to the building owner. He decided, I don't want to replace everything. That's really costly. I'm gonna test. I'm gonna test a few of them. Okay, now we're gonna have to do some sampling. All right, we're not gonna test every sprinkler. This is a destructive test. All right, when you send it to the laboratory, we put it through an oven, it does get destroyed, right? The sprinkler releases, that glass breaks, so that link falls apart. You're not getting these samples back. So you just take a sample of them down, and we give you analysis, and then we go, okay, if that represents what you have, here's what could be going on. So how big of a sample are we talking about? NFPA does have a requirement for that. They say that a representative sample shall consist of either a minimum of 4 sprinklers or 1% of the sprinklers in the area, whichever is greater. So we need to break this sentence down a little bit here for you. So 4 or 1%, so what are we talking about? Well, if you have 400, 1% of that is 4. 400 or less, you're going to send in 4. Now, once you start getting above 400, if you have 500, you got to send in a minimum of 5. Minimum, if you got 600, it's 6, right? Pretty simple. So that's what you're required to sample. Now it gets into, well, which sprinklers do I sample? These should not be the best looking ones. They should not be the worst looking ones. They should be at random, ideally, right? Shouldn't be the ones that are easiest to grab, right? They should be at random, ideally. And they need to contain each type of sprinkler in that area. We're going to talk about area in a moment. So when we're talking about type of sprinklers, we're talking about different manufacturers, different mechanisms. So if we all of a sudden on screen here, I have a pellet and I have a fusible link, these would be considered different. But I want to clarify, I mentioned it briefly before, we do not evaluate the water distribution pattern as part of the periodic test. So only difference in these sprinklers is the deflector. You can consider them the same type for the purposes of the periodic test, right? The mechanism is the same, the manufacturer, everything else is the same, the temperature rating. So in this case, we could consider these the same. But this one over here, maybe it has the same temperature rating, but it clearly has a different style of deflector. Even if it was the same manufacturer, different style of deflector, we're going to want to get that in the sample. And I often get asked, okay, let's say I have 400 sprinklers in an area, but I have 5 different types of sprinklers. How do I deal with that? Well, then you really, I mean, at minimum, you're going to have to send in 5. Remember, the requirement is a minimum of 4, 1%, but that's just the minimum, right? In your case, you had 5 different types. You need to get each at least represented by at least one sprinkler. So you may have to send in more, right? You could also consider different sample areas, and we'll talk about that in a moment. But that's when it comes down to, okay, how many do I got to send you to meet this requirement? It's going to be 4 or 1%, whichever is greater. Now let's talk about that phrase, sample area. Again, this is another thing not defined in NFPA 25, and that actually is on purpose. Your sample area should be, if you're a contractor, it should be a discussion with your building owner. Well, what do you want to treat as your sample area? And if you've heard me give this talk, the easiest way to explain this is, let's take like my building here. I have a conditioned office space. I have a laboratory space. It's also conditioned. And I have an unconditioned warehouse. All right. If I wanted, I could call my whole building here one big sample area. Maybe I have 400 sprinklers, so I take 4 at random. I got 1 from the warehouse. I got 1 from my lab, 1 from the office. I send them in, and 1 from somewhere else randomly. I send them in, I get them tested, and the one in the warehouse fails. Oh, shoot, right? Because it was in an unconditioned area, maybe it's more susceptible. Well, now we'll talk about failures more a little bit later. Now I have to replace everything, the whole building, because my area, I defined it as a whole building. What I could have done, which totally up to the building owner and you as a contractor to educate him on this, you could have traded the office and the lab, both conditioned, both similar environments, as one area, and the unconditioned warehouse as another. Now, yes, you do have to take 4, 1% from each. So now I did have to take 4 from each. I doubled essentially in my scenario here how many samples I have to send. But if I do have one failure, I've now kind of isolated it. Now I only have to replace the warehouse, right? And in my case, the warehouse is just a few, it's not very big, just a few sprinklers. Most likely, I'll just replace the ones in the warehouse, and then I'm going to test the ones in the office, right? There does get to be this cost benefit analysis that needs to be done by the building owner in consultation with the contractor about what's going to be the best thing for me. And there's no easy answer. It depends on the situation, number of sprinklers, environments they're in, type of sprinklers. Again, if you see they got O-rings, when I talk about those failures, why, do we really want to test those? Those have a high failure rate. Those should just be replaced. So that's when we talk about sample area. I can't tell you it's per riser, it's per system. Nope. If you want to treat it per system, you certainly can, but you don't have to. You could treat it per room. Doesn't make sense per room, right? I only got, in my little conference room here, I only got 2 sprinklers. No sense in testing, right? Just replace. I got to pull them down and replace them anyways. But at some point, you get these big warehouses. Do you want to treat that as one big area, or do you want to break it down by system if there's multiple systems? So that is what we're talking about with sample area. I already talked about the other section shown on screen. Each type of sprinkler shall be there. And then obviously, again, we talked about we're not going to take the easiest ones to get, the best looking ones, the worst looking ones. We're also not going to take ones that previously have been replaced, right? So if I have 50-year-old sprinklers, I pull 4 down, they pass, great. What remains can remain in service for another 5 or 10 years, depending on what environment you're in. Well, those 4 that you pull down, you replaced with 2024 sprinklers. The next in 10 years, I don't want to pull those ones. You got to pull from the older ones, right? So those are just some key things to remember about sampling. So I've talked a bunch. Let's actually bring it back. I like to reset ourselves. We talked about field testing, right? That's what we're talking about today is a requirement NFPA 25 that periodically I need to either replace or test. We went through the replace or test initial test intervals. You talk with your building owner and they go, yep, I do want to test. I think that's the better option. Okay, before you're going to go and sample, you're going to want to define your area with that building owner. Okay, how do you want to break this up? Then you're going to go and do the floor level inspection. You're going to replace anything that clearly fails that inspection. And then what remains, you're going to pull your sample down. And that's going to be 4 or 1%, whichever is greater. All right. Now this is where Dyne comes in. So I have a brief slide here just on Dyne Fire Protection Labs ourselves. Like I mentioned before, we do carry that ISO 17025 accreditation that the annex material suggests. And we do work with AHJs, making sure they are comfortable with our analysis and that everything's on the up and up. We do have quality at top of mind. Our biggest differentiator, we like to say, is our speed. This is all we do. This is our sole focus. We will turn these results out in 5 business days or less. Rush testing next day in most cases is available for an added fee if you really need it that much quicker. But we understand as contractors, look, you're going out, you're doing the work, you're doing a big chunk of this document, right? You've done all these other tests, inspection, maintenance, and there's one little part about a lab you got to wait. You need our result to attach to it so you can bill them and you can get paid. We understand all that, right? So the faster we can do it for you, the better off you are as well. And beyond that, we try to make this as simple as possible. More likely to be done then, right? And getting this done is not only important for yourself and your business, but the building owner, safety of people is in that building. So to make it easier, more likely to be done, we do offer free sample kits, and that's what I'm showing on screen. You could put your standard sprinklers in there. And the other kit I'm showing on screen is a dry sprinkler box. It's a telescoping box. I'd recommend just reusing for dry sprinklers. A lot of guys will still have those boxes that they come in. It'd be easy enough to reuse that box would be what I'd suggest. But if you don't have a box, again, I don't want you to have to, how am I going to ship this to them? We have boxes for you, and boxes with padding, right? Secure. I can test a sprinkler in just about any condition except for damage. If it's already activated, the bulb's already been broken, there's nothing I can do for you, right? So we want to make sure they arrive safely in the intact condition, ideally in the condition they were where they were on site. If it's full of loading, leave the loading on there. We're going to plunge it with that loading in there, right? We're going to see how does that impact the results. And these kits, at least in the contiguous United States, the standard kits, we do offer free shipping both to you and back to the laboratory. The dry sprinkler kits, the return shipping, just the size of the kit, the weight of the dry sprinkler, there is a shipping and handling fee on those. But the free kits down there, the free kits both kits are free. It's just the shipping and handling. There'll be a charge on the dry sprinklers. But again, that's all to make your life easier. Again, if you want to do this testing, you pull your samples. How am I going to get it to lab? Recommend you take advantage of that free kits. We have one other thing that helps make your life easier, at least when it comes to sampling, which is the Drop Master. I'll play a brief video in a moment here, but this is a business that's been around for quite a while. They make essentially a vacuum system, right? It removes the trapped water in your drops, so you can take these sprinklers out without the mess and the smell. This is something we had acquired back in May of 23, I believe. So we do manufacture and produce right here in Minnesota. It's just we're in Woodbury right now, right outside of St. Paul. The next town over is where we have our shop, and we do manufacture these units here. So let me play just a brief promo video if this is something that can help you take sprinklers. Let's hope this works and shows up for people.
No more buckets and tarps. No more water or smell. No more hassle. The Drop Master DM12 makes replacing sprinklers easy. After draining your sprinkler system, simply connect the DM12 to your drain and wait for the system to get to vacuum before proceeding with your removal of sprinklers. The air pulled through the sprinkler system by the DM12 and the vacuum it creates will carry trapped water with it. The pump inside the DM12 will then discharge the collected water where you want it. When done for the day, drain any remaining water in the drum. Drain any oil collected from the muffler. Top off the oil in the vacuum head reservoir and clean the Y strainer basket on the suction line. This will ensure your DM12 remains in good working order and is ready to go for the next job. And built to last right here in the United States. The DropMaster DM12 will quickly become one of your favorite tools. Order yours today. Contact Dyne Fire Protection Labs for current pricing information and lead times. Parts and repair services are also available.
All right, so yeah, just something that could make your life easier, sampling. Let's get back to it then. You've taken the samples, you've sent them to a laboratory, hopefully Dyne, and hopefully you've utilized their free kits, you've utilized their DropMaster product, make that part of the process easy. So it arrives at the laboratory. So now let's give you a peek behind the curtain of what happens there. Well, the standard requires that we test these for sensitivity and functionality. That's what it says here. After the visual inspection, when we get them at the lab, we're going to test for sensitivity and functionality. Let's start with that second part first, functionality, right? That's a loaded term. Like there's a lot of things in that. Really what we're looking for, it's the very next sentence, that the waterway fully clears at just 7 PSI or the minimum listed operating if a dry sprinkler's listed the minimum pressure above that. A lot of people do question this, have issue with this, would like to know the pressure. You know, a lot of people will go, well, my system's not at 7, it's at 50. Would it operate at 50? Unfortunately, that's not how the code is written. The code is written at the minimum operating pressure, right? So when it was listed, many of these listing standards have a safety factor. It went off well below that, right? And if it's not going off at 7, the minimum it could be used at, I know your system today is not at that, but it could be used at that according to its listing. That's where we're going to check it at. So all those people that mine's at 50, would it go off at 50? It isn't going to change the overall pass fail. The standard, the way it's written, says we're going to test that functionality, that waterway clearing at just 7 PSI. So let's talk about now the sensitivity. That's actually the next section shown on screen. So what are we talking about sensitivity? This is a common misconception about what we do. If you have a 155 rated sprinkler, you plunge it in the oven, you think, oh, does it go off at 155? That's not what we do. We don't tell you what temperature it goes off. We tell you how long it takes to go off, what time. So we're giving you a time, not a temperature. We plunge the sprinkler above its activation temp, and we monitor how sensitive it is to go off. And that's how the code is written. Why is it written that way it's really an economic decision, right? When we talk about periodic testing, we can check. There are various benchmarks you can choose to check. If we chose to check temperature, it'd probably take hours per sample. It'd be very costly. Imagine the number of sprinklers that are out there. It's just unlikely to be done, right? So the standard decided at a minimum requirement, okay, the sensitivity can be done a bit quicker, which makes it more economical. And that's what the benchmark that was chosen for sprinklers, right? So it's something that's done at the listing time. There's requirements there. There's also requirements here for sensitivity, how long it takes to go off. Unfortunately, like a lot in science, it's not as simple as it seems. You give me a sprinkler and you want to know, well, what does the standard say? How long can that sprinkler go off? It takes a bit of an equation to figure that out, right? The requirements are not written. If you look at the standard, and a standard response sprinkler has to go off in 350 seconds. Nope, that's not what it says. It says that it has to have an RTI of 350. And that's an abbreviation for response time index, which is just this fancy equation shown on screen. I'm just giving you a brief background. Nobody tune out right now like, I don't want to do all this math. You don't have to. We provide you the RTI, the response time, right in the report for you. I'm just giving you a little peek behind the curtain. If you ever wondered, how does this RTI relate to time? It's through this equation. You plug in a bunch of variables. So we have the oven, how fast that velocity, that air is flowing. And the oven, by the way, is just shown on screen, an example of a plunge oven that you would use this specialized piece of equipment. At its heart, it's basically a giant convection oven. It's expensive to just control it to the degree we do and the accuracy it has, but it's essentially just a giant convection oven. So we have our velocity, our oven temperature, the ambient temperature outside of it, temperature rating of the sprinkler, all that gets plugged into this fancy equation and out spits your RTI, right? So we do provide you, I'll show you a report a little bit later. You don't have to do this, but if you're ever wondering how does that relate, that equation right there is how it relates. So now let's talk about statistics. And again, rambling on here, and it's a lot of information. I'm taking one little column in the document, really expanding upon this for this hour. Let's reset ourselves, put ourselves back on the ground. We know NFPA 25 says that we have to either replace or test our sprinklers at intervals, right? Hopefully you never need the system, but if you do, it better work, right? So we're going to get these things tested once in a while. Corrosion, things can happen. We're going to annually inspect these. If they're good and the building owner chooses to test, we're going to sample some down. So we're going to take 4 or 1% of our area, which isn't defined in 25, right? The building owner is going to define that with you and figure out, how do I want to break this up? Take those samples down. Hopefully you're going to use our free kits, make sure they arrive to our laboratory safely. Hopefully use the drop master if you have drops to help you so you don't have the mess to deal with. Once it arrives to laboratory, again, we're going to go through our processes here. We're going to check it in. We're going to let it get to ambient conditions. We're going to plunge it in our oven. I showed you briefly the oven there. And let me go back. I actually had a video. It's an old one, but it's a good one. It's got a little bit younger, a little bit thinner me in it. And this video is just very roughly, this is when we were R&Ding one of the ovens many, many years ago. It just gives you a little bit, again, we showed a picture of the oven, but just kind of the process. You see me there, I connected it to about 7 PSI of pressure, plunge it in the oven. On the oven itself, there's a little timer in the background. When you plunge it, it goes, okay, here's the time started. Then we have a little bit of a time lapse happening here, but the sprinkler's in the oven. This is kind of looking down the tunnel of the oven, and off it goes, right? And then when it releases, that pressure releases, it can detect that, and that's how we get our time. So that's really what we're doing when you're sending a sprinkler. You're using the specialized oven to monitor how long it takes to go off. Let me go back to my slide here, and we were going to talk about failures now. So we put it in the oven. Hopefully it's gone off, right? Hopefully it's gone off in the required amount of time. It has an RTI that's acceptable. That's not always the case. If it was, we wouldn't be here, right? We wouldn't have to do this, but that's not always the case. And I'm providing you here, I pulled these, I think yesterday, 211. 5.4% of the sprinklers tested at Dyne have failed. So about 5% of what we've received from people have failed. So I get asked that question often because you may have to decide, am I going to replace or test? And an owner's thinking, well, if it's always going to fail, I'm better off just replacing. They don't always fail, right? About 5% of the time they do. And with that, I will give you, with any data, right, there's always some considerations to make. With this one, keep in mind, we sometimes do get sprinklers, and I'm showing a bunch of them on screen, like the sprinkler in the middle there that my pointer's at, clearly has detrimental loading or corrosion, right? It's held that water seal on, right? So that one should have been replaced before we sampled. We should have never seen that. But I understand we have some building owners that, nope, I want to see that. Maybe that sprinkler does represent them all. Maybe it's in some sort of pool area, built up some nasty crud around it, or it's leaking. And the building owner, no, I don't, you're telling me to replace it. I want to give me some data on that. We gave them the data on it. So just keep that in mind when we're talking about failures. We are getting some sprinklers that clearly should have been replaced at the inspection time, at the annual floor level inspection. And I break that down for you here, just if you're curious. Again, what's the most common reason for failure? We have about 1% that just fail to activate. So that means we have a bulb, maybe it's lost fluid. We have a fusible link, maybe it's corroded a bit, and then the solder tries to melt, but the two links are held together. Same thing can happen with a pellet. It just doesn't activate at all. Those would be, the worst case scenario if it doesn't activate at all. Right now, we're not going to get any water out of that. That would be, in my opinion, an impairment. Right, we're getting no water. We have 2% that failed to activate on time. So they did activate, just slower than we want. So you are going to get water, but not as quickly as it's designed. In my mind, that would be a critical deficiency. Right, you'll get some water, but not as quickly as you need it. And then the most common reason for failure is they activated. So everything happened like it should up in the activation, the bulb and the mechanism, but the water seal remained in place. And again, most common, that's actually what I'm showing on this picture here. These all activated. You can see there's no bulb. There used to be a bulb in this far one on the left, but it looks like, again, leakage, isolated corrosion on the water seal. That corrosion is holding in this case, it looks like a Bellevue spring seal, a little washer there. It's holding it in place. So even though the bulb's cleared out and the water's supposed to be able to push that water seal out of the way, it can't. It's fused together. It's corroded. Same thing here. We have a copper gasket fused on. Here we have the copper gasket and the little cap piece just all stuck on. That's what I'm showing at the top screen. The most common reason for failure. The sprinkler does activate. You're just not getting any water out of it. All right. And then sometimes you can get a combination. That's where if you're trying to like add up these percents, sometimes you double dip where it activates slow and then it also doesn't release. And a special caveat, I always bring this up because even though I mentioned O-rings and it's been 20 some years since they've been listed, they are still out there. About 4% of the sprinklers we received in 24 still have that O-ring design. And I pulled the failure data on those, and 54% of the time they fail, right? So this is why O-rings got the black eye. They had those voluntary recalls. This is what you want to look out for. Again, this is something if you see, we just want to get these replaced, okay? I understand, like I said, if you send them to them, we'll still get you the data. But at 54%, if you're going to send in minimum of 4 or 1%, right? Chances are very likely you're going to have a failure in that group, all right? And that's the bottom picture here. I'm showing some O-rings. These didn't come from these, but these are just various O-rings. There's an O-ring seated in there, an O-ring seated in there. There are documents online you can Google that are very good about identifying O-ring sprinklers. They give you models to look out for, but also just general guidance. Maybe many of you have heard if it's flat, send it back, right? You're looking across here. See this on screen again. I'm sorry if those can't see the presentation, but on screen here on the left, I'm pointing to a raised Bellevue seal, right? That's a Bellevue seal. That's not an O-ring. No, it's raised. When we get O-rings, it is across there. It doesn't have that raised feature, that cap. It's just straight across in many cases. So that's where that phrase comes from. But I would highly recommend you familiarize, if you're a contractor yourself, with those and help the building owner identify those and just get those replaced. But it's something to keep an eye out for. Like I said, still 4% of the sprinklers we saw still featured that O-ring water seal design, which notoriously high failure rate. So keep that in mind too with that failure statistic. Not only are we receiving samples that should have been replaced at inspection, floor level inspection, we're also receiving 4% of O-rings that really we shouldn't, right? We should have all those replaced. And lastly, let's talk about what fails. So let's say you do unfortunately have a sprinkler that fails to release, slow to release, or just doesn't release at all. What are we going to do? Well, NFPA says that where one sprinkler in a representative group fails, all sprinklers represented by that result need to be replaced. So again, we're going back to our sample area. How did we define that? Again, if I take my building and I have my warehouse and lab and office, and I treated that as one big area, and I have one sprinkler in the warehouse fails, I now have to replace everything, right? In the laboratory, in the office, that's all getting replaced because my area, what my 4 sprinklers that I sent represented the whole building. Where if I were to separate that out, and I try to use this picture here as a good example. Let's say and this isn't the case, but this sprinkler on the left came from a conditioned office space, and the sprinkler on the right came from an unconditioned warehouse or somewhere where there's just more corrosion. You can see it's a little bit more corroded. If I were to treat all as one, and that one that looks more corroded is probably more likely to fail, right? That could be detrimental. Now I got to replace everything, including the ones that look on the left. But if I were to separate out those 2 different groups and I send 4 of each, 4 from the office space, 4 from the warehouse, now when I have a failure just in the warehouse, now I only have to replace that. So that's where that cost benefit analysis, do I want to separate out and do more testing up front, or do I want to take the chance, lump them all together, and if I do have a failure, now I have to replace? Common example I see many times is high-rise buildings. A lot of times we'll get by floor, right? Because they don't want, on the first floor, there's something going on, there's some pool, or maybe some floor had some weird fumigation, some cleaning or something, and you have one failure on one floor, and now all of a sudden the whole high-rise building's got to get replaced. Examples like that are where people try to break these up. So you can limit how much you have to replace from a failure. Again, if you're asking for my recommendation, it would be separate based on environments, because that's really what we're looking at, is how did the environment affect the longevity of that sprinkler? And like I'm showing on screen, we got one that looks pretty pristine, right? And then we got one on the right that, okay, that's clearly been around either some vapors or some moisture, some sort of corrosion's happening on that right sprinkler. So that environment, these came from 2 different environments. So again, if I have one fail, we're going to replace everything that was represented by that failure. Also shown on screen, example report. You can find these online if you want to zoom in, look closer. Top just has, again, the job information. Middle has your sample information. So we provide you the year it was manufactured, the manufacturer, the model number, temperature rating. We provide you what the release mechanism water seal. So you can look to that to see, did it have an O-ring sprinkler? We also provide you pictures. There's a link in the email when you get this report that you can click on. It shows you pictures before and after testing. So if you again, it's a destructive test. Once I do this, it's gone. It's getting recycled. The metal's getting recycled. But you have those pictures as evidence of what was sent in, what condition was it received in, and then after it was tested. There's even a picture through the water seal, so you can try to see, okay, was there any blockage through there? And then the middle part of the service we provide is really this analysis. Again, it gives you response time index, which is how the requirement's technically defined with that fancy equation. And then it tells you, did the water seal fully release, partially release, which would still fail. Sometimes the water seal releases, you'll get a little bit of water, but it doesn't fully release, right? So we're not getting as much water as we want. And then like anything, a bunch of fine print. And I think this just explains, again, if something fails, if it passes, what to do. So that's what our report looks at. Before I move on, I have one more slide and then we get to questions. Again, I always like to reseat ourselves because it's a lot of information I'm giving you. So again, we know NFPA 25, whether you're on the current 23, you're on a previous edition, it all says the same. Periodically, we got to get sprinklers tested. The editions may disagree on the frequency. Things have changed based on data, based on just time. As we go longer, we have more data based on failure rates. We know that 5 years harsh, 25 fast, 50 standard, right? We know we have these frequencies. Talk to the building owner. They've decided I do want to test. I don't want to have to replace everything. Okay, building owner, what's my area? He goes, yeah, you explain to him the cost benefit analysis of, okay, you can do smaller sample areas and limit what impact a failure may have. He chooses to separate his warehouse and office because they're two different environments. Great, you go out, you do your floor level inspection, you replace any of those things, leakage, corrosion, loading, paint detrimental to sprinkler performance. And again, we talked about how in 23, a little bit of paint on the arms, not considered detrimental. That would have been a cause for replacement in previous editions. You take your samples down after you do that and you replace anything that clearly fails. You have your 4 or 1%, whichever is greater of your area. You use one of our kits, you get it to our laboratory, maybe use a drop master to help you with that. Gets to our laboratory, we check it in, we run it through that test in that oven. We get you your time, we get you your response time index, and we issue a report that says whether it passed or failed. So you got your 4 sprinkler report here. You look through and wow, there is one failure on that. Okay, that means all sprinklers represented by that need to be replaced. If you get a report and all 4 fast or 1%, however many you sent us, everything in that area passes, great. What remains can remain in service for another 5 or 10 years. At which point you either need to do this, either replace all of them or test again, right? And if it's 5 or 10, only depends on the environment. Doesn't depend if it's fast, standard. You're going to do that subsequent testing. I should mention too, if they ever do reach 75 years of age, I believe that's still the requirement in there. You're just going to everything at 5 years. You're going to start doing it more frequently. Again, we need to build that data to show at 75 we can go to 85 without problems. So we start to push. If you ever get sprinklers that last that long, we start to push the data set that we have. So that's the field service test as described in NFPA 25. My last slide here is just highlighting everything I talked about thus far is considered routine testing, right? So the testing described in this section is to determine if the sprinklers have maintained a level of sensitivity that would allow them to operate as expected during a fire. So this is something we're going to do at the 5, 20, 25-year window, but that does not mean at year 6, at year 12, at all, at any point when you're doing the floor level inspection and you look at it and you go, is that detrimental? Is that a problem? Send it in and get it tested. You are not beholden to the 4 or 1% rule, the sample area rule, right? That's what this annex here, this A531 talks about is, look, everything I've talked about, all these requirements is routine, but you can certainly use non-routine testing to analyze other issues that could be going on. And I just want to highlight we can be a resource for that, particularly, again, those detrimental to performance. I pulled the picture on screen from our document I talked about that talked about, okay, here's a picture and here's the response time and whether it passed or failed to give you an idea what detrimental could be. On screen, I'd ask many, in your head, do you think this is detrimental or not, right? And many of you may know, many may think you may know. This one, in this case, I looked at the data because I myself didn't know. It looks like it might be detrimental. In this case, it was. It went off a couple seconds too late, but it did go off. But this loading essentially acts as an insulator, right? Not only does the heat have to heat up the metal pellet, and now it has to heat up all the other junk around it too, right? So it takes longer to go off. But something like this, if you weren't sure, is this detrimental, or the building owner doesn't agree with your assessment, let's send it to a lab, let's evaluate. In this case, just send one. Let's send one that's representative, right? If there's just one that looks like this, just replace it. But if you got the whole facility look like this, let's get it evaluated and assessed. And you're not beholden to all these other requirements that I just went through here. Those are just for the routine, the 5, 20, 25, 50, as it currently says in 23. So I appreciate it. I went a little long-winded. I'll stick around. If you guys have to go, you can email, you can call here. My email is just grant@dyneusa.com, but I will take time now, and I'll stay late too to answer questions that come up. Jenny, can you help me start asking questions?
Sure. I think I'm gonna start at the bottom and work my way backwards. That looks like it'll be a little easier. When a head does not go off at 7 PSI, your report must say it failed. If requested, can Dyne provide the PSI that it does go off at up to a reasonable point, say 20 PSI, knowing it's still technically failed? I've gotten that question before.
Yeah, we get that question quite a bit. So the question, if you couldn't hear, was, okay, you failed it at 7, my system's at 20. Can you at least provide the data that said it went off at 20? We just currently don't have the bandwidth to do that. That takes quite a bit more time, more equipment we got to keep calibrated. Something if there's high demand, maybe we could think about. We're cautious about it too, because how would that data be used? You could talk to an AHJ and look, it didn't go off at 7. I find it very hard for an AHJ if NFPA, the code, the committees decided that no, it's a failure, it needs to be replaced. It seems unlikely an HJ is going to go out on a limb, take on that liability. Go, no, it went off at 20, it's fine. But I know that's a common request. Many people would like us to provide that extra piece of data. It'd be something, again, our ISO accreditation, we'd have to roll into our scope. So currently it's not something we offer out of the box. But if we continue to see much demand, we can consider it. We can keep thinking about how could we accomplish that, and also the risks. Again, what are people going to do with this data? How are they going to interpret it? But it's a common question, but no, currently it just, did the water seal release or not? Yes or no, fail. And that's about it. Next one.
If the leak was from the thread connection point and not the seat.
The thread connection point, is that a problem? Now, the sprinkler itself, so we're talking about leakage. What if the leakage was actually coming from these threads, slowly dripping down?
Oh, I'm sorry, I forgot the beginning of the question. It's up a couple. Can the corrosion on a sprinkler head caused from leakage cause it to activate prematurely?
Can corrosion cause it to activate prematurely? That's a good
The leak was on the thread connection point, not the seat.
So it's kind of two things there. So if it's leaking around the threads and we have some corrosion buildup, let's talk about that. And then also, could that cause activation? Leaking around the threads, I'm concerned with it, just the fact you are still going to have that corrosion problem, whether it's leaking around the water seal or the threads. The impact of that is still going to look something like this, right? And we're still going to, what I'm showing on screen, if you can see, you're still going to have corrosion around the water seal. That's going to be a problem. We're still going to replace that. And keep in mind, once you remove the sprinkler, you're not allowed to put it back in, right? So whether it's leaking around the threads or the water seal, still going to be a problem for the sprinkler itself. Because if that water, I guess if you have an upright sprinkler, if the leakage is just, it's not going on the sprinkler, that's a different story. But if you have a pendant sprinkler, you're going to end up with water flowing across the sprinkler, whether or not it drips, right? It may not even notice it. It may just slightly go down and evaporate before it ever accumulates and go down, but that's enough moisture to cause the corrosion. The question of, can it activate prematurely from corrosion? That's a great question. It's a no if it's a fusible link, right? That's not impacted by the corrosion. But, or sorry, bulb, I correct myself there. It's no if it's a glass bulb. It shouldn't be affected by corrosion. But if it's a fusible link, you could have corrosion that kind of eats away. I talked about corrosion kind of fusing two metal pieces together. Maybe it causes some pits and some cracks in the solder and the links. It might be possible. It's nothing I've analyzed myself, but that's just where my mind's going, is could it eat away at the solder? And then that would cause, again, if you weaken that solder connection, I talked about high heat where the solder becomes malleable and not enough to release, but enough to kind of squeeze and move around and reshape itself and then reharden in a much less desirable shape, that can cause premature activation. I suppose it's possible if the corrosion ate away at that, you could have some premature activation. So it's a good question, maybe something we want to research.
So a couple questions here. I'll see if I can just get to this one. It might be a good time to talk about this, the language that's out there. If I do UL sample testing early, would that push the scheduled testing out?
If you do, so the first part, if I do UL sample testing, again, let's try to correct that nomenclature of just the field service test, right? More than UL, ourselves are doing the testing as well. And then if I do my testing early, does it push it out? Well, let's say you're required at 50 years to do the test. You did some testing at 40. I mean, you're still required to do it at 50 years. I don't think, and remember, if you do it at 40, and this is just in my example, you are required to do subsequent testing every 5 or 10 years thereafter. So let's say 30, just so it's not convenient. If you did it at 30 and you're not required till 50, I think you can still wait till 50. The 30 was just for your non-routine info, right? You did it at 30, it passed, great. You wouldn't have to test till 50. But once you do it at 50, then that starts your clock of every 10 thereafter. And I briefly mentioned at the end, if you ever hit 75, if they last several cycles, then you're going to increase that to 5 years. Or if you're in a harsh environment, you're just always going to be on 5 years all the time. Another one just crossed my mind too, some special consideration. I think kitchens are called out specifically. Anything in a fume, not a fume hood, thinking of a laboratory. Anything in the kitchen hood full of grease, right? We're going to replace those every year. We're not going to bother and test those. Typically, there's not a ton of those to begin with, but also the grease, the insulation that is called out in there, that's one you're going to replace annually. But no, I don't. I guess to answer your question, does testing early change your window? No, I think testing early is a non-routine testing. What I talked about at the end, that's just info only. You still are required 50, 60, or again, if you're at 25, 35, I don't think that changes that.
Okay. Can I classify what I want my test sample area to be after the testing has been completed?
Can I classify my sample area after the test?
Okay, I've never heard that before.
It's tough, right? Because if you sent in extra sprinklers, maybe. I guess it's possible. I'm not in enforcement. Dyne is not in enforcement, right? I don't know. We just every job, what we call job, every job you send in is every sample area, right? So if you sent us 4 sprinklers from Dyne, one failed in the warehouse, and then after the fact you try to go, well, no, I'm going to split the warehouse and the office space. You don't have enough sprinklers with those 4 to satisfy the requirements of both, right? I guess you could send in 4 from each, after the fact. You could satisfy it that way. But that's just something you have to keep in mind if you try to change your sample area after the fact. Do you have enough to satisfy the requirement of 4 or 1%? So again, if I took 3 from my office, 1 from my warehouse 1 failed, and my office looked totally fine. You couldn't just separate because you only have 1 and 3. You don't have 4 of each. So then you'd have to send in another 1 from the office and 3 from the warehouse. I mean, that's possible. I think technically, you have to talk to your AHJ. Ultimately, in my mind, I'm thinking like, look, the ones in the warehouse, different environment, those for sure we want to fail. If the office was different, they just didn't realize it until after the fact. Again, this is my opinion. There was that disclaimer at the beginning that, where was that? The opinions in this are my opinions, not of NFPA or any of its technical committees. My opinion is that I don't necessarily have a problem as long as you satisfy the requirements. If after the fact you sent in 4 from the warehouse, you separate after the fact, redo it. That's okay. We just want to make sure, and 4 is really small, of like 400, right? We talk about 1%. Is that really representative? Again, it gets into that economical, the debate at the committee of, well, how many should they send? We want to make it, again, economical, so it's more likely to be done. We catch these issues, right? 5% of them failing, that's a big deal, right? That could be dangerous to anyone in the building, property in the building. But yeah, could you? I think you maybe could, but you're going to want to check with your AHJ. But ultimately, again, I'm thinking grand scheme of things, look, we want to get those ones in the warehouse, in my crude example, those ones replaced. If you just split it after the fact, that's still happening. Okay.
We covered some information on failures, but I don't know how specific we got or what we retain. The question is in regards to ESFR heads or standard responses or a specific type of head that sees more failures.
Is there a specific type of head that sees more failures? No, we obviously have a lot of data, and we do share that data with the committees and others, and we could provide more. We could break it down by different types. We are hesitant to break it down by manufacturer model. You know that we're not looking to call it anyone specific, but are there some models that have more failures than others? Yeah, I mean, the O-ring's the best example, right? Like clearly that was a problem that was brought to the industry. Um, hey, this ain't working, right? And we continue to monitor for other instances in that. Do ESFR specifically fail more than others? Not necessarily. You got to keep in mind with this data too, again, another consideration, like ESFR, we're getting them after 20 years, where a standard response has been out there for 50 years. So even if my data for ESFR is, I only have one failure out of every 10, and that's a bad example, but one failure out of what, every 100. If I have two failures out of every 100 on standard, you think, oh, ESFR is better. Well, you're getting it 30 years sooner. That one's had 30 more years out in the elements. So that's just something to keep in mind when we start to look at different types, especially if because again, we're getting the sample at the initial test is the first sample, and then we see subsequent testing as well. So we're typically not seeing ESFR, or sorry, standard response at year 10 or year 20 like we are. We're not comparing apples to apples. We get the occasional one if, again, they have some sort of non-routine issue going on, but typically that means that, okay, there's some issue going on. I have loading or something. So it's hard for me to say if ESFR are better than standard, that kind of thing. It's better for me to look at water seal, like the mechanism types. That's why we provide that. For me, that's what it is. So what? So the ESFR has got a bigger orifice. Okay, the water seal itself, is it a Bellevue seal, which is this washer? Is it a copper gasket? Those kind of data, that to me, that's where I'm really interested in the design of it. Whether the the manufacturers, they typically have all the different designs and different types, and like O-rings, right? We clearly know that's a problem. Everyone else, like the Bellevue seal, that's the most common today. It used to be copper gaskets, then O-ring got popular for a bit, and then Bellevue seal, this washer, it's like a washer, but it's raised in the middle. So when you tighten down the release mechanism, it's under some tension. So not only does the water push the water seal out, but the springing mechanism, that's where the spring comes from, the tension it's under, the water seal wants to pop out. Those have a very good track record. If they didn't, again, we bring that to the committee and others and make sure people are aware of it. But if there was specific examples, email at the end there was that lab. Again, I'm not going to email specifically this manufacturer versus this one, but if there's design questions or fast response and standard, I can provide that. Again, you're not comparing apples to apples in most cases.
Okay, thanks for that.
Mm-hmm.
There's questions about harsh environments.
Yes,
harsh environments include outdoor areas that are exposed to severe temperature changes and exposed to many weather elements, like here in Minnesota, maybe. Yeah,
right. Yeah. So question, harsh environments, is outside consider that, and is specifically cold outside? Is again my opinion that outside would be considered harsh, in my opinion, but it depends. I mean, the elements really too. I think of not just temperature, but humidity is a big one because of the corrosion that humidity can bring. So a very humid environment. It's not specifically stated. You could talk to your HJ, but I would recommend, you could always do some routine testing to see. I don't know if this is harsh. Talk to the building owner. Look, we're in this really humid climate. Let's just check a couple. And if you are finding failures before we get to that window, okay, we need to get on a more routine window. As a contractor, it's a service you can provide. And here's the data to support that. I think there is a clause somewhere in there about driving this with data. Like if historical data says you need to increase the frequency, increase it. If it says I think it even says if you can decrease it. Typically these are pushed pretty far back as it is, but outside, specifically cold though, that one I wanted to talk about because of dry sprinklers. I get that one all the time. They have a freezer, they put a dry sprinkler in there, right? Well, it's exposed to cold, just cold on its own in a freezer. Is that a harsh environment? In my opinion, no, that's what the dry sprinkler is designed for. right? Is the cold. And if that's where they're going in most cases. And if that was the case, why do we have a separate frequency for dry? So in that case, the dry sprinkler is designed for cold, not the outside necessarily, but just cold. If that's the factor, I don't consider that harsh. But it's something yeah, it's a great question. It is a tough question. I knew that would come up, or harsh in general. That's why I bring up some examples. Um, it depends on the sprinkler you have. Again, what kind of environment you're in, what is it made of? Is it stainless steel? Then again, could be one of your listed corrosion resistant where you can go a bit longer. Is it wax coated in a swimming pool? Okay, that buys you a little bit of extra time. That wax insulates the moisture from the sprinkler. But in general, outside, yeah, in some cases, yes, but I specifically wanted to call it dry sprinklers and cold because that's, in my opinion, it's designed for the cold. So that the cold by itself should not call it a harsh in that instance. The cold by itself, again, with the regular sprinkler, isn't going to affect performance. It's the moisture or lack, it's fumes, chemical fumes. That's what's we're really looking for corrosion. Harsh environment could be loading. I've seen a lot. I don't know if they're from like metal, some sort of shop where they're dealing with some molten metal and things. That oil just gets built up around these things, and that would be considered harsh too. So not just corrosion, but loading.
If a head does arrive with the element knocked out of it, is it noted that it couldn't be tested, or is it marked as a fail?
Just noted. We'll just delete it. We won't charge you for it. Now, if it's one out of a group. Now, if you keep sending me a bunch and we're paying the shipping, if you're using a free kit, there may be some sort of charge for that. If we're paying all the shipping, you keep sending me broken sprinklers. But no, in not every case, usually it's like, look, they sent us one broke in transit. No, sorry, we can't test it. We won't put it on the report, and I don't want to put it a failure because I don't know if it would have passed or failed. You know what I mean? There's nothing we could do with it.
Receiving team does usually reach out if they find a broken one. If it looks like a broken transit, we definitely do try to reach out, get a hold of you and talk to you about it and see if you want to send us in a replacement, which sometimes people do. Or if there's, say, 3 remaining sprinklers, sometimes we just test the remaining 3. We leave it up to you. So usually we do reach out if we notice an element is missing.
But just to avoid that, again, use our free kit if you can, right? It's got that padding in it, whether it's a dry sprinkler or standard sprinkler. Don't overpack them. Our kit's really designed for, I say 4 to 6. Like if you got big old ESFR sprinklers, you're probably only getting 4 in there. You got little tiny K-factor ones, you could probably fit a bit more, but don't overpack it, right? It's when we get a lot of sprinklers, and we've even seen it where they're just balled up and thrown in a box and they're bouncing around and all knocking into each other, especially if you frangible bulbs. Ain't gonna work, right? So use our kits, avoid that at all costs, package it right. That's why we provide the free kits as well, right? Make it easy, but also let's make sure we can do what you want. Use our free kit, put it in there, put the padding. If you got 8 sprinklers, you use 2 kits. We use 1. Just make sure they arrive safely.
If a head activates before the RTI number, is that a fail?
If a head activates before the RTI, is that a fail? No, it's the other way around it. RTI is maximum. I should have covered that a bit better. Let me go to that slide. This says the sensitivity does not exceed 350 for standard, 65 for quick, and 50 for ESFR. So that's a maximum. So we want to see we want quick response times, right? We want them to go off pretty quickly. We're plunging them in the oven well above the activation temp. There's really 4 different temperature ranges we do. We don't want to take every sprinkler and put it in at 800 Fahrenheit, right? Because the ones that are rated for 155 are all going to go off like that really quickly. We're not going to see any differences. So we have 4 different ranges, but the ones that are rated for 500 Fahrenheit, they're rare, but we do occasionally see them. Those ones we have to put in at 600, 700, 800, so they go off in a reasonable amount of time for us. So it's the sweet spot of we want to see differences. We also don't want to wait hours and where it's not economical and it costs so much, then it's more likely not to be done. But that's the maximum. So we want to see RTI less than that. That's a good question too. When it's listed, it's actually a range, like it has an RTI. Like this might have to be X to Y, right? In this case, it's just a maximum. If it's less than 350, good to go. We do not evaluate like this premature activation. That's not part of the periodic analysis. Is it going to activate at 125 instead of 155? Again, we don't measure temperature it goes off. We're plunging it at a static temp. So your 155 is going in at 275. That's for that one. When it's in the oven at 275, we monitor how long it takes to go off. Would it go off at 155 or 125? We don't know in that analysis. We don't currently offer any more than that. That's not required for periodic purposes. That may show up in a bit quicker response time and a bit lower RTI, but there is no set, there's no minimum. It can go off with an RTI of 1. Now that one, if I've never seen that happen, but that would be like insanely fast. We'd probably contact you and, hey, this is very odd. But just to clarify, you want to see RTIs below what the report says. And I think our report, again, it's in a slide, so it's kind of hard to see. I don't know if I zoom in, no, not let me zoom in, but here it says requirement less than or equal to 350. This was a standard response sprinkler. So in this case, in this sprinkler, I'm showing a failure just because it's on a failure slide. And this is just an example I made up here. It's supposed to be 350. It was 361 was the RTI. If you don't understand that, don't want to understand that, we also provide you, here's the time, but that RTI went off at 127. Looks like in the small print, it's supposed to go off at 123. So if you'd rather visualize and mentally work with it in time, we can, but we also do plug in that equation and give you it in terms of RTI if you want it.
So quite a few people on the line. Do you want to keep going with a few more?
Yeah, I can keep going. Yeah, we got people here, might as well.
Yeah. If we send in an O-ring sprinkler, will it automatically fail?
Nope, it'll be testing. Nothing the standard says it has to, and we make it very clear we don't identify, call out any recalled products. I would love to. There's just, I think NFPA or one of the associations might be working on this, of just trying to make a centralized location for all the recalls, right? That's our concern as a business for liability reasons. Like if we call out one recall, we got to call out them all, right? We've established we offer that service. So no O-rings. There's even a disclaimer on a report. One of these jargons here talks about, look, we do not identify, remedy, recall. That's on the building owner. So no, an O-ring won't specifically be, it can pass. Again, I had that failure statistics of 50-some% fail. So there's still half of them do pass. So you'd get a report, you'd get the time if you're really curious. It's just extremely likely that an O-ring, I mean, if you send me 4 and they have a 50% failure chance, it's just getting unlikely that all of those 4 are going to pass. But it still doesn't mean, I mean, you should be identifying these O-rings. And again, I throw out the phrase voluntary recall. I think that's what it was called. I'm not an expert on that. I think those have ended. It's a weird place. It's kind of outside of my realm, but no, we don't. If it says O-ring, we evaluate it based on its performance as required in the standard. Standard doesn't say we have to fail O-rings. That's different than 1920 sprinklers. I briefly mentioned that. Anything older than 1920, the standard does say that has to automatically fail. That has to be replaced. It doesn't say it has to fail. It says it has to be replaced. So if up here in my year marking it says 1919, or I mean we've seen early 1900 sprinklers, no matter what the result is, the requirements, it's just going to say fail, no matter what it is. And that's just built into our programming based on the code, the NFPA standard. So there are instances where that does happen, where something you give me, it doesn't matter what it is, it's going to fail, but O-ring's not one of those.
We get any that older, due for the trophy case in the front.
Yeah, we got a little trophy case, yeah.
Some kind of great examples in there. I don't know how old they are, but here's a good question from Tom. What is the typical cost for a test? I did respond to him. I can attach the pricing sheet.
Yeah.
$65.
Yep,
No matter
$65.
5-day turnaround.
Yep, doesn't matter the type, what type of sprinklers. That's your 5-day turnaround price, 65. Again, that includes your free shipping. If you're in the contiguous US, that standard kit, both to you and back to us. So that can add up. I think that's something that should be considered. I know a lot of places when you consider price, you just look at the flat. Well, what are you getting with that as well? Fast turnaround, you're getting that free shipping. Yeah, it's about 65, a sprinkler, not a job of 4, a sprinkler.
We got a couple of nice comments from people that have used the Drop Master. Thank you for those.
Oh, very good.
reached out to those and asked for a testimonial on those. We'd like to have some rooms. Here's a question about fails again. If the failed head is one of the multiple types in the sample area, only those heads need replacement, ? Not everything in the sample area.
No, not the way the current, so the question is, let's say I got 4 different types of sprinklers and I sent in 4 for my area. I had less than 400 sprinklers in total. And one of those types fails, can I just replace that type? Let me go back to my image here. Let's say I sent in, these are 3 sprinklers, and just imagine there's another one that looks like something like them. If this one down here failed, I only have to replace the ones that look like that. That's not currently the way that I interpret the standard. The standard, if I go to the failure language, says that all sprinklers within the area represented by that sample shall be replaced. I interpret that as, look, your area 4, one of them failed, all that area needs to be replaced. But I can see how you can read it of represented by that sample. If you wanted that, I think you'd have to say like by that type in that sample. Do you know what I mean? It's something you could bring to the committee. So just as part of NFPA Global Solution, just so you're aware, I'm no longer, I don't participate in the committees. I don't have a vote. But anyone in the public, it doesn't have to be me, anyone in the public can submit a comment. You can go to nfpa.org, go to the standard, in this case, NFPA 25, click on the next edition tab. And when it's open, it's not open for comment all the time. There are specific windows. NFPA, like I talked about, 2017, 2020, 23, next edition's 26. They're on a 3-year cycle. So they're constantly opening that window, getting public comment, public input, sorry. And something you could make a suggestion and see what the committee has to say. You can also just submit a formal interpretation request in that nfpa.org, go to the standard and see what they have to say. I might do the same. I can do that. I can ask for the committee to respond on, hey, what if just a single type? But the way I currently read it is, look, if you send me 4, whether any of those fail, I don't care if they're all different types, whatever that represented, it represented my whole building, then I'm replacing my whole building, not just that one specific type. There was that one question the individual asked if, well, after the fact, could I just change my area? My opinion, I'd ask her HJ, but you would have to, again, you only send me 1. That's not a representative of the area. You'd have to send me 4 of each, right? And who knows, maybe when you do that, then all of a sudden there's other failures. So that's the only caveat if you are going to do that. In my mind, my opinion would be, okay, you do want to just replace, like on screen here, you sent me 2 of each, these one failed, I just want to replace these. You got to send me 4 of each, so send me more to analyze, and then you could treat that as, you could do that. I mean, especially, I have no problem, you define it ahead of time. Look, I'm treating this, even though they're all in the same warehouse, if you will. I don't know why, but half the building looks like that and the other half looks like that. Look, I'm going to treat the ones look like this as my sample area. The ones that look like that as my sample area. You can do that, and then you just got to make sure you satisfy the requirement of 1% of each. Just gets trickier when you do that, because I'm sure they're not all as clear cut as this, right? You might have one that looks somewhat in between. Which group does that fall under? It gets messy. I don't think the committee wants to go that far. But the type is a good one. I'm going to write that down, and I'll ask the committee, and Jenny, I think, collects the questions, and I'll get back to you. I think we should have your email from the registration.
Yeah, you can do that. There's a few of them I think we'll get back to via email.
I'm ready for any more if there are.
Yeah, let me jump back over to the Q&A. I think we answered most of those in the chat window.
I see we got a bunch still on. I appreciate you sticking around. Again, you don't have to. This will be recorded, distributed after. If you got questions, let me throw that back on screen. You can reach out to the lab at any time.
Can you clarify the sprinkler hood testing intervals / requirements?
Yeah, sprinkler hood testing. I think that comment I made about sprinklers inside of kitchen hoods. I always want to say fume hoods because, again, coming from a laboratory. But there's a requirement in here that talks about, you're just going to replace those. Again, I'm looking at the current edition, but I believe it's been in there for a while. It's under inspections, I believe. I can always send it out too after the fact. but it specifically calls out sprinklers in kitchen hoods. Just getting on a replacement of every year on those.
There's another question. I can probably try to answer this one while you're looking that up.
Yeah.
Does Dyne maintain records of locations tested in the past that are accessible to building owners? Well, we do retain the records, and usually our policy is to share those with the company that sent them to us. They're not really public information, if that's the question that's being asked. We usually only report that back to the company that sent us the sprinklers for testing. We'd probably point you back in that direction if you're looking for past testing information.
I might just have to send, so when the email goes out, thanks for attending, is there a certificate?
I'll make a note on the hood question.
Yeah, I'll send that. I swear it was right here. Not seeing it though. What else we got while I'm still looking here?
Physically damaged heads or painted heads included in the 5.4% failure rate.
Physically damaged are as long as the damage is not as long as it still holds pressure. If the release mechanism is gone or the water seal is just it's not holding pressure, then I can't do my test, right? I have to hold 7 psi. That's how it detects it. So physical damage to the deflector, to the thread, yeah, that stuff's represented in there. What was the other one? Damage and what?
Damaged or painted.
Painted would be, yeah, any condition. Again, we don't refuse to test anything. When we test it in the condition as received, if other than the one we can't, we're not refusing it, we just can't if it's damaged where it doesn't hold pressure. Yeah, if you send me one that's totally covered in paint, I'll still throw it in there and it would cover those. Just remember that paint is one that's changed over the last couple of years where now you are allowed a little bit on the arm. Again, your state, you're probably several editions behind. You're like, what the heck is he talking about? Mine says paint doesn't matter where it is, got to be replaced. It's something in the newest 23 edition. Yeah, that does include that failure statistic paint. I think we have some in our little trophy case if you ever visit where paint's just holding the release mechanism like a bulb. The bulb has got a bunch of spray on it and it's holding the bulb together. It strengthens it. So that pressure as it heats up, it's not breaking when it should.
Here's a question about the drop master. Does the DM12 have something to easily connect to CPVC drains as well or no?
The drop master terminates in a 1. Let me pull it up on screen if we can show it. 1 inch NPT. We do provide you an adapter. So it terminates in a cam lock, a 1 inch cam lock fitting, and we give you an adapter to take it from that cam lock to NPT, but only to 1 inch. And that's all we provide with the drop master. You'd be expected to whatever connection you need, whether that be to CPVC or again, we got 2 inch drains. You just gotta, most guys with drop master, you'll just have some of these connections. You go up to your drain, whatever you gotta do to convert it to 1 inch NPT, and then the drop master will hook up to it.
It's a question, are we getting a cert with 1 CPD point? Yes, I will send out a certificate of attendance. Many people do use that, as I'm told, for their NICET. So if you stay for the webinar, yes, I will send those out via email to your email that you registered with. If you had issues and you were jumping around from program to program, it might not document the whole time, just reach out to me and we'll see how to get you one of those. I think that's most of the questions. A few other kitchen related ones, I think we'll just probably save for individual responses.
Yeah, I wish I could find that. I swear.
Well, the other one about the kitchen, I'm not sure about this. So could you elaborate about the requirements for sprinklers in kitchens in Friends covered with grease? Should they be tested again or replaced?
Again, I swear.
Loading or corroded, wouldn't that be the same?
Yeah, sprinklers covered with grease would be loading. And
Level inspection?
I wish I had it right here. Again, we'll send out that language for kitchens, but I believe it just says annually you're just supposed to replace. We were thinking of actually, something actually we're talking about today, of doing a little research study, a little paper. Like we've done one on the past on loading. We loaded it up to different degrees. Just a white paper that shows you how much impact that had. We did one on paint. I think that's the next logical one is, okay, let's load some up with grease and let's see how big an impact it has. Not to say I'm trying to get around the, look, we don't have to replace these every year, but let's just, people are curious, how much does this impact it? But yeah, it would be a type of loading. So instead of just heating up that mechanism, you're now going to have to heat up the grease. That's probably going to melt off first, and then it's going to go off. So it still would probably go off. I don't think that's a constraint. It's going to go off, but it's going to take longer than it should. I mean, it's the same situation we have with wax coated sprinklers, right? Wax and grease, pretty similar. But where some sprinklers are specifically, they're sold to you wax coated, they have a little bit different requirement because of that insulating effect of the wax. Wax first melts off, and then the sprinkler goes off. And it's just a known, look, if you buy a wax coated, this is its test parameters, its requirements. So I would expect no difference with grease. The difference being when you install it, the grease is being added on after the fact. You're not really designing it like with the wax coated sprinkler with that in mind. But we'll get you that requirement. I apologize. I don't know why I can't find it there.
There's a couple that we might have not got to. There's quite a few people on there, but I will take a look through those and discuss those with Grant and see if we can get you any answers on those. Before everybody signs off, I just want to thank everybody for being here. We really appreciate awesome attendance today. It's a record breaker for us, so that was really exciting. We'll be sending you a survey and appreciate your feedback, including any future topics that you'd like us to cover. We do send a link to the recording of this webinar. It might take me a bit to put that together. That should come out today or tomorrow. Our next webinar is scheduled for Wednesday, May 14th on firefighting foam testing. And there will be a link also in that follow-up email from me if you'd like to register for that. We do post the webinars on the Dyne website. We have a page just for webinars, dyneusa.com/webinars. So you can always check out what's new and coming up. And we also like to put things on our LinkedIn and Facebook pages and also in our monthly newsletter. So if you haven't subscribed to our monthly newsletter, that would be a good thing to do on our website. Go down and click on the subscribe button and you'll always get the up-to-date information, including news, sometimes industry news, and what's coming up here. Do you have anything else you want to cover?
No, I think that was it. I appreciate you guys listening to my spiel and yeah.
Apologize for the some of the technical issues we're having. My understanding is it was working better in the WebEx app than it was in the browser. So I will address that in the next webinar to put a link to that so you can all download that app ahead of time.
Yeah, hopefully you guys learned something. If you need more questions, again, contact information's on screen. They'll get you to the right place, including myself. Be happy to help you further.
Thank you, everybody.
Take care. Bye.